KP multiple choice questions. So now a bit of your 13 multiple choice questions. Oh, yeah, KP is an A-level topic. Double check that because I don't want to be. Yeah, it is year 2 topic, rate equations KP. However, you might be taught it in year 1, year 12, like myself. So, which statement about KP is correct for this reaction in the gas phase? The value of KP is independent of pressure. The value of Kp increases as pressure increases. The value of Kp increases temperature. Okay, I can already eliminate B. That's false. Only temperature can affect the value of Kp. The value of Kp is independent of pressure, so it doesn't depend on pressure. That is true. The value of Kp increases temperature increases. Well, temperature increases is going to shift to the forward reaction because that's negative is XO. So it's going to shift to the endothermic direction to oppose the increase in temperature. And therefore we're going to have more reactants. So it's going to be like 10 divided by 5, but in this case we've got 10 divided by 10. More reactants. So what happens to the value of Kp? Clearly decreases. That's just an example. So it wouldn't increase. The value of Kp is independent of temperature. No, it's dependent on temperature. So the answer is A. Question 2. Hydrogen reacts with hydrogen. Nitrogen reacts with hydrogen is exothermic direction. Okay, so that's key. Delta H is negative. Do I know what is negative? What? The number? No. But I know it's negative, and that's going to probably help me in this question. Which change increases the equilibrium yield of ammonia but has no effect on the value of the equilibrium constant Kp? Add a catalyst. Catalysts have no effect on the equilibrium yield. Increase the partial pressure of nitrogen. If I increase the partial pressure of nitrogen, that could work, but let's look at C and D. Decrease the temperature. Well, if I decrease the temperature, because the forward reaction is exothermic and backwards reaction is endothermic, therefore backwards reaction is endothermic. If I decrease temperature, it's going to shift to the exothermic direction to oppose the decrease in temperature, aka increasing the temperature. So therefore, it will increase the equilibrium yield of ammonia. And will decreasing the temperature have no effect on the value of Kp? No, it does have an effect on the value of Kp because then we've got more products divided by reactants. So that's false because it needs the conditions. Two conditions are increase the equilibrium yield NH3 and also no effect on Kp. Decrease the total pressure. If I decrease the total pressure, so it's either between B and D. If I decrease total pressure, would that increase the equilibrium yield of ammonia? Well, if decreased total pressure is going to shift to the side with more moles of gas, so no. So the answer is B. And it makes sense. Increase partial pressure of nitrogen, equilibrium shift to the opposite side to increase the pressure of that, the equilibrium yield of that. And obviously, pressure has no effect on Kp as well. Question 1. Okay, so we're going to do the same thing as, the EKC video, going through the multiple choice questions. I, C, E, M. Obviously M and P, but in this case we only want the mole fractions. SO2, O2, SO3. Initially we have 2 moles of sulfur dioxide mixed with 2 moles of oxygen. So we're going to assume that moles of SO3 is 0. Total amount of fluid gases at equilibrium is that. Oh, this is going to be a tricky one, isn't it? Yes, clearly going to be a tricky one. In experiment, 2 moles of sulfur dioxide are mixed with 2 moles of oxygen. The total amount of the three gases is 3.40. What is the mole fraction of sulfur dioxide in an equilibrium mixture? So what I'm going to say is that I've got X amount of moles. I don't know the equilibrium moles. I don't know them. I'm going to say that I've got X. So if to go from 0 to X, I'm adding X. To go from 2 to X, I'm doing no, this is going to be 2 minus X. Because think about it, the change in moles, because this side is increasing, this side must be decreasing, that must be 2 minus x, and that also must be minus x, so therefore 2 minus x. And that is equal to 3.40. So 2 minus x plus 2 minus x plus x equals 3.40. Just a bit of algebra. Minus x plus minus x minus 2x minus 2x plus x minus x. 4 plus 4. 2 plus 2 is 4. 4 minus x equals 3.40. X equals 0.60. Okay, what's the mole fraction of sulfur trioxide in equilibrium mixture? Well, the mole fraction is going to be the number of moles of sulfur trioxide, 0.60, divided by total number of moles. What is the total number of moles? 3.40. Okay, and then that should give me the answer. 0.176. And then question 3. The equation for the combustion of butane and oxygen is that the mole fraction of butane in a mixture of butane and oxygen with the minimum amount of oxygen required for complete combustion is. The mole fraction of butane in a mixture of butane and oxygen with the minimum amount of oxygen required for complete combustion is. That is just so confusing. I'm just gonna be honest. But the mole fraction of butane. I don't know if this is going to be the correct method, but let's try it. It's better than just repeating the question over and over again and not doing anything. But surely if I do this, CE, and because it doesn't obviously an M, mole fraction, and I'm just going to use the molar ratios in the balanced chemical equation. So 1, 6.5, 4, and 5. No, that's not going to work though, because that's just not going to work. Just don't think that's going to work. The equation for the combustion of butane and oxygen is C4H10 plus 6.5O2 forming 4CO2 plus 5H2O. The mole fraction of butane in a mixture of butane and oxygen with the minimum amount of oxygen required for complete combustion is A 0.133, B 0.153, C 0.167, D 0.200. Well, there's already a mistake because there's 2 C's. That should be a D. Maybe I'm overreacting. Maybe I'm over-exaggerating what we need to do. Because we've got 1 to 6.5. We're trying to find a minimum amount. No, I'm trying to find a minimum mole fraction of butane with a minimum of oxygen required for complete combustion. We've got 1 mole of C4H10, 6.5 moles of O2. Therefore, the total moles in the mixture is 7.5, and therefore the mole fraction of butane with minimum of oxygen, the mole fraction of butane, the number of moles of butane, which is 1, divided by the total moles, 7.5. Oh my days, and that would give you 0.133. That makes complete sense. It's just going through the question. So 4A, perfect. 2B, perfect. 1B, 1B, 3A. Perfect. Obviously, I got it wrong the first time. Well, I was struggling with it. And then I realized mole fraction of butane. Well, I asked ChatGPT and and it helped me because the mole fraction of butane, so 1 mole divided by total number of moles. That's it. Now, 1b. Okay, mole fraction of sulfur trioxide, an equilibrium mixture. Oh, right, okay, so because that's 2 mole ratio, it's not going to be, you know, I didn't see that. It's actually plus 2x. So what it actually is, it's 0.60 times by 2 divided by 3.40, which is 0.353. 2 mole ratio. That makes complete sense. And that's the end of the multiple choice question.